Hi, let's figure out how to find the distance between two complex numbers. And this is a problem. You can see the plots for z1, which are, let me get my pen here, 7 plus I, and then z2, which is 2 minus 7i. So z1, your real number piece, 7, imaginary piece, up 1, and then z2, positive 2, and then negative 7i would put us down 7 on the imaginary axis versus the real axis, okay? All right, so the idea of finding distance between these two is something we can handle at a very basic level, calculation-wise, and it is trying to find, in a graphical or visual sense, this distance right here. If I go from this point to this point on the complex plane, how far is that? Well, we can do the work, and basically what it amounts to is a right triangle and its hypotenuse. Now, there was a nice formula back in geometry class everybody learned called the distance formula, and you could apply that here. But if you're already dealing with a plot, it's actually pretty easy to count out and figure out what the difference in horizontal values versus the difference in vertical values, and then kind of treat this like an a squared plus b squared equals c squared thing. So I'm going to use d here because that's kind of what the problem is labeling the distance as. That makes sense. So a squared plus b squared equals d squared. All right. So we can actually, since we have the plot, we can actually count and say, okay, from 2 over to 7, that's a distance of 5 units. And then in the imaginary axis here, we've got a change of height that goes from negative 7 up to positive 1, so a total of 8 units. All right, so if we apply the Pythagorean Theorem, like I said, we can do this pretty quick. So you can have 5 squared plus 8 squared equals d squared. Obviously we want to take the square root of this sum, so let us get rid of the squared on d by square rooting both sides, and you'll have 25 plus 64 in there. Now, just a mathematical note, if we weren't dealing with a geometric or a real planar distance here, I would have thrown a little plus minus on out here. Because mathematically, when you bring the radical in, you know, you've probably heard me say this before, but we want to bring the plus minus to numerically understand what's going on for both those values. However, here, since we're talking about a distance from point to point, we are satisfied with just the positive version of this number. Okay, so that will simplify. We will get d equals 89, I believe. Square root of 89. And yeah, so a little over 9, not quite 10, so 9 point something, 9.4, 9.5, somewhere in there. All right. That's the distance. Okay, now I'm going to keep this video going, and we're going to go to the next page here and talk about midpoint. So the midpoint, and you know, so I got to pause because some of the things that could really slow you down or confuse you is labeling, right? Some of the labels you run into here, z sub 1, z sub 2, it's just a way of, and you've seen this on your graphing calculator, your TI-84 does this. It's just a way of using the same letter for a variable, but showing that you have two different ones that you want to keep track of. So it's kind of like saying, hey, number 1 is this person, and number 2 is this person. Subscript allows you to kind of do that. So if we're going to talk about complex number z, the first complex number I'm going after is 5 minus 3i, and the other complex number is 5 plus 3i. Interesting. You could probably tell I grabbed this right out of the work. And so what we're doing here to get the midpoint, and I'm going to label the midpoint M. but it's just the average. So if we were plotting these points on a plane and then trying to find the point that's exactly halfway between the 2 points, we would be one at a time finding the average of the x's, or I should say the real number pieces, and the average of the imaginary number pieces, which are like the x's and y's. So think of the number here. The complex number is a real piece, and then it's this imaginary piece over here, and they both have a coefficient, right? So we're going to find the average of these two things. So when you're averaging two things, you are adding them up and dividing by 2. All right, and we're going to get this midpoint number here. Add those b values up and divide by 2. So you guys are, you've heard this before. You've got a real number, an imaginary number, a real number, an imaginary number, and together the whole thing makes what's called a complex number. So we're going to take the real number piece and we're going to average those two, and we're going to take the imaginary number piece out of both of those and average those two. So there's your imaginary number piece, and here's your real number piece. Okay. All right, so the numbers here are going to actually go pretty smooth, because if you average 5 and 5, you're going to get 10 over 2, which is obviously going to reduce back to 5. The average of 5 and 5 is 5. Okay. Breaking news. And then -3 and +3. Okay. So you add those two up and divide by 2. Well, that's going to be 0 over 2. And this is cause for hesitation, because a lot of times people have to remember, what's that division by 0 rule? Or is this a no, we're not dividing by 0 here. We're dividing 0 by 2, which is legal. We can get away with that. So 0 cut into 2 pieces is still 0. Okay? So that is also the imaginary number piece. But here's the thing, even in complex number world, 0 times I is still 0. Just like 0 times 7 is 0. It's nice to know that in the complex numbers, if you run into a 0 for that b value, you are back in the real numbers. So our midpoint happens to be right at 5. Okay? Plus 0i, but you don't have to type that in. All right? I hope that helped. It's just the average of the a values, the average of the b values, and then you put it back into the a plus bi format. And in this case, we didn't have a bi because b was 0. All right.